Hello, in this video we're going to be discussing parabolas. Now our geometric definition for a parabola says that any point on the parabola, which I'm referring to as P, which you can see right here, this is our point P, is always the same distance from the directrix being this line down here. Notice it's horizontal. So the same distance from this line as it is from some point called the focus. And so here's our focus point. And notice that point P at this moment is 7.65 units away from both. I have this right angle here because the shortest distance from this line to this point is going to be at the right angle as opposed to as an angle, which would be longer, right? Because that would make a hypotenuse for a right triangle if I were to draw that in. Okay, and so what I can do here, I have it set up so that if I take A and drag it, notice that the line is always the same distance away. Again, so like right now, point P is 9.73 away from both the directrix and the focus. And I have a trace on to show you all the places that point P has gone for this statement to be true. Speed this up a little bit. Okay, our distance from the directrix and the focus are getting smaller and smaller and smaller, and that's probably the smallest it will be right there is for it to be 2. Both P is 2 away from the focus and the directrix, and then it'll start to increase again. Let me speed it up some here. And so this right here, again, every single one of these points that has been traced is the same distance from the focus to the directrix. And this is the shape a parabola takes. We call it parabolic, and it looks just kind of like an arc. And in this case, it's an arc that's opening upward. Okay, so that's our definition for a parabola. We'll do more of this in class. For now, we are done.